Welcome, everyone. Today's podcast is going to be a super interesting one in light of what's going on geopolitically. It is on chips, on semis, and everything in between, supply chain resilience. And to talk about that subject, today we have the Chief Commercial Officer of Baya Systems. His name is Nandan Nayampali. Welcome, Nandan.
Hey, thank you for having me on, Carlos.
So, as I mentioned, would love to get into the subject of semiconductors and how the world's being affected by them. Of course, some of the most valuable companies in the world are in that space. And you could argue that's
hmm
probably the biggest growth area for tech. And other people would say that it's the applications that ride on top of them. But let's walk me through your background before we go into that, because anybody who finds you on LinkedIn will just be wowed by all the companies you've been in. You've been part of Amazon, the Alexa team, but more importantly with ARM, which has obviously changed the world in its compute and everything else. So yeah, walk us through, what you did, how you started in this world, and sort of the key things that you got from that career before you ended up where you are today.
Yeah, sure. So I am a geek or a failed geek, depending on how you look at it, because I have kind of moved more to the business side. My background obviously was in computer science and computer engineering. So it was a combination of the two. And my first job was an interesting one. I started off at AMD in the glory days when the Pentium processors were built by Intel and AMD was trying to compete. And I had an offer from Wall Street to go do what you do at Wall Street. And I got this offer that said, I want to build a 400 megahertz microprocessor in 2 years when Pentium was at 50 megahertz. And I said, sign me up. So my first job was actually at AMD, which obviously now is also resurgent and seems to have taken over the server market over from Intel. And then the startup bug bit. So I actually jumped out of AMD into a startup in what's called electronic design automation software. Went through a VC phase there, jumped to another startup in a similar space, but that introduced me to what's now called and popularized by ARM as semiconductor IP. And the idea behind IP, which is going to be the basis of majority of my career, is really about best in class capabilities that are designed by some groups, but not necessarily manufactured by them. So most of you are now familiar with ARM, where I spent about 16 years of my career. There are companies like AMD and Intel that build their own microprocessors, NVIDIA that build their own GPUs, and of course, they build their microprocessors as well. But there are companies that specialize in building specialized microprocessing units or graphical processing units, but they don't actually manufacture, they license that design to companies that do. So companies like Qualcomm that make smartphone processors may actually license their CPU from ARM. Samsung does the same. So it's a very interesting model and a very interesting industry that has actually enabled a lot of innovation outside of the big companies that were fully vertically integrated. So in the old days, for example, AMD, Intel, TI, all the Japanese manufacturers were fully vertically integrated. They had full designs, each had their own instruction set, each had their own software stack, and each had their own fabs. But that was a model that wouldn't scale. It just got too expensive. And so you started getting the breakdown and the supply chain started developing on, okay, TSMC will manufacture for you. Synopsys and Cadence are tool players that'll help you take your top level designs and help them make them manufacturable. And that kind of spurred an industry that was capable of doing different things. And that has been kind of the bedrock of the innovation that you see over the last 2 or 3 decades. And so ARM was a great learning ground. And also, it was kind of a nucleus of a lot of change in the way the semiconductor industry has been. What was a gleam in somebody's eye, let's say 20 years ago, is pretty much in your day to day. You don't even notice the things around you that are powered by processors from things like ARM. There's probably in most houses, especially in the Western Hemisphere, there's probably at least 20, if not more, ARM-based processing units around you, whether it's in your headphones, whether it's in your TV, whether it's in your washing machine, whether it's in your car, and clearly in your smartphone, right? So that was a great learning ground for me. And also, it helped me understand fully the supply chain the global, the regional impacts of technology innovation. From there, I kind of went to a different spot in about 2020, end of 2020. I moved to Amazon to take Alexa into third-party devices. So I got a little bit more of a background on not just all the hardware that's developed for these various devices, but the software that's needed to start getting AI, in those cases, voice to the edge. And since then, I've gone back into startups that are trying to disrupt the industry. So my background's pretty vast on the semiconductor side, pretty diverse and eclectic at the same time.
Well, walk us through a little bit about what Baya Systems is then, so we can like go through how you got there and why you chose to work with them and what do they do.
Perfect. So Baya Systems is a Series B startup now. When I started with them, they were just past Series A. It's a little over 2 years old. And what Baya Systems does is it helps connect up different computing elements, different components on die. So usually the assumption is, oh, you just design something and then you connect it up with wire on chip. But usually the majority of the efficiency gain is how efficiently you move data from processor to processor, from processor to memory. And what Baya does is what's called network on chip, or fabric that can be designed and implemented into chips for every application. But in particular, we're looking at the high performance, very differentiated applications in automotive, in data center, in networking infrastructure, in edge AI acceleration, etc. And the theme that some of the listeners may be hearing of in recent times is the notion of a chiplet, not a chip, but a chiplet, where instead of taking a full design and putting it across one giant chip, we're beginning to see a market developing where you can build smaller chiplets and then connect them up into the same package for a more complex solution. Chiplets have been what changed AMD's agility in the last decade. Chiplets have been used a long time in even the smartphone world, but now they're coming into their own because there's different new capabilities that are being added. And now instead of you taking the main chip designer taking all the risk, you're having suppliers taking some of that risk and providing best in class. So that's actually the cusp of the industry that we're looking at, and that's where Baya also plays. How do you make this very complex process easier? How do you actually make the designs that you're planning? How do you know that they're going to deliver on the performance ahead of actually building them? Because it's a very expensive process to get to the end, and
Yeah.
you better be ready to build the right thing towards the end.
You've done a great job of walking us through the evolution of not only chip design, but also how the demands have changed over the years. And one of the books that I'm sure you've read because it's super popular is Chip Wars.
Mhm,
And, it's probably a good launching pad for us to have a chat about the
mhm,
role that chips have played, not only in our key systems for
mhm.
everything, all the way to our defense. And so, in this trajectory that you've had in your career, what do you see in terms of the elements that are now so strategic geopolitically? What are the things that you're witnessing that worry you, that you're seeing change because of what's happening? It's a broad question, but it's just
Mhm.
a whiteboard to paint on what it is that you've seen in the chip war facade in your career.
Yeah, so finally, it is control and economics, right? Most things boil down to that. And if you think about it, obviously the industry would say, finally, it's not the hardware that matters, it's the software. Actually, it's the service that finally matters, right? So uh, I care that my smartphone does things for me that I need it to do. I don't care how it's done. The software has been the important part and still a pretty large portion of the cost and where most of the effort is. However, what has become very clear is as things get more complex, you need the right hardware to do all of that. So if you think about what are the key challenges, having the performance and the capacity to do that. So if you think about AI training, AI inference, which has become kind of the real battleground, you can do it on older hardware, but you're always going to be slower. And finally, speed matters, performance matters. So in order to do that, you have to push the boundaries of the design. The idea that you want to, especially geographically or regionally control it, has always been there, right? Initially, it was about, hey, I can't afford the $50 chip when my entire budget for my classroom is $10 per child. So the idea of building lower cost, locally sourced chips that fit your budget was the intent. Now it's like data is key, information that can glean from it is key, and I need the right compute power to do that. If I own the compute, if I own the storage, then I own the data. So the chip wars have accelerated primarily because what's sitting on top of it or what's being manipulated by it is becoming more and more, what should I call it, sacred or desired.
Well, we're seeing that with Trump's putting tariffs. I mean, by the time this episode goes to publish, it might have been retracted, so you never know. But 100% tariffs, right, on anything that is imported into US from a semiconductor point of view. And I would love to hear what you think that will do to the industry, because yes, there's the caveat that if there is already local manufacturing, it won't apply. But if that's sort of the extreme version of what you were just saying, walk us through
Mhm.
what your industry is thinking right now. Like, what is the impact of this? How does that change things in light of the fact that where we are today is a hyper specialized international operation with
Mhm.
componentry coming from the Netherlands, other components coming from America? How does that get impacted?
The jury's still out on how that will play out, right? So clearly, TSMC, which is Taiwan based, right, is the source for more than half the top level silicon that's shipped around. Samsung similarly has a pretty large market share on those types of chips. Intel's trying to compete at that top end, and you've seen what's going through. So if you think about it, there are three different countries with potential barriers in between them. What I do see is there will be carve outs when it comes to important things. So, as you probably heard, TSMC seems to have bypassed the blockade, right? Which is also because that the technology is fundamental. The other thing about semiconductors, especially deep submicron, as it's called, right, um, is that you can't just do it overnight or even over a couple of years. A lot of the latest fabs take years to kind of not just build, but then it's almost always a recipe rather than a pure science that you have to get it right. And there's so many factors and variables in it that the same factory in Taiwan versus the same factory in Arizona will still have a lot more tweaking and tuning to be done. The complexity is pretty high. So while TSMC started putting down fabs in the US as well, they were not the state of art latest. They were setting that up so that they could move there. So it's not going to be something that can be turned overnight. The demand is immediately overnight, so it will have to sort itself out. Now, in the long run, there will be more and more incentive for investment locally. And it's not just the US, you'll probably see similar things happen in different parts of the world. You've seen India announce their silicon program. Of course, their target is much more at the lower end for microcontrollers and things that are going to be broadly deployed. I know I'm going all around. It's more of a flavor. I don't think there's an easy answer because it's a complex problem.
Yeah.
But what I can say is we are testing where the points of pain are and what people are willing to do to kind of make that work.
Yeah, it sounds like whichever way you look at it, there's going to be some change, and that change
Hmm.
comes with having to come up with new designs, maybe that adapt to
Hmm.
those changes, just to make it
Hmm.
financially feasible. It sounds like Baya is very well poised to take advantage of that change because you basically are in the intersection of optimization, sounds like. So, walk us through who you think your customers might be in the next decade, because with all this change, geopolitical
Hmm.
change, is there a world where you're servicing the compute requirements of local national areas, but with different cost bases and therefore redesigning of maybe stable platforms, but at a different cost basis. Walk us through what the world looks like in 10 years from Baya's point of view.
So I think if you take ARM as a template, what ARM helped to do is actually give compute capability to pretty much 300 plus companies and regional sectors as well. So if you see what's happened over the last 2 decades, if you will, right? There were always microprocessors and things like that, or microcontrollers, if you say, that had specialized processing. But with ARM, what you saw was now smartphones come from any manufacturer across the world can license an ARM processor and build their silicon, right? So you do have locally grown, very low cost handsets in China and India that are built off of licensed processing. You see the same thing now. The other aspect of licensed design that can actually make the economics change, just like what you saw Amazon do. Instead of buying a, let's say, I'm just making up numbers here, but a $10,000 high-end server chip, if they take the first cost of the design and build their own Graviton processors, you could effectively get, because you're now buying directly from the foundry and not having the overheads of packaging, cost, margin, et cetera, that's built into a supplier like an Intel or an AMD or even an NVIDIA, they could get 1/10 that price effectively packaged because they're taking the cost of the design up front, they're taking the risk up front. And you do see that happen with companies like Huawei, Baidu, Xiaomi in China doing that. You're going to see the same thing in Europe with companies like Atos, Bull doing that and expanding it. And you'll see very similar things occur in the rest of the world. Every country is beginning to take charge of at least some key infrastructure, some key design that they want to develop, build local industry, as well as have some control over it. I think that just proliferates. And I would say another theme on this is the idea of open source, what Linux did to software. You've always heard of x86, which is what ARM and Intel build, right? The x86 architecture. ARM is another architecture that was competing and has proliferated. About 10 years ago, a movement started with what's called RISC-V. It's written as RISC-V. The RISC-V processors are open source. And so that a lot of sovereign programs have adopted that because that gives them flexibility to go build their own. So what I see over the next 10 years is, yes, there is the notion that if you want to go to training, NVIDIA still has a huge ecosystem advantage, huge execution advantage that may continue to grow or at least hold its own. But for a lot of the smaller or mid-range or proliferated applications, you will see control going to localized companies because IP becomes a part of it. Now, companies like Baya does sell into a lot of the data center players. They may be startups now, they may be mid-range companies, they may be suppliers into the automotive world, suppliers into the networking infrastructure world. So we do see that picking up, but it's not just Baya Systems. I think a number of IP players will supply into that next world.
Would it be a fair statement to say that Baya is a chiplet focused firm?
We are actually an IP firm that focuses on system on chip, right? So you can call it one or system off chips, which it would be what chiplets are. So the intellectual property that we have actually goes into any of those designs. What is unique for us is we also have the software and tooling that helps you analyze across not just single, but multiple, and that plugs into existing tool flows as well. So what our goal is to make designing multiple chips or multiple chiplets much easier and have a system view to kind of take a slightly different view, right? So we always have a geocentric versus a heliocentric view. And most compute widgets think inside out in a lot of ways, whereas we kind of look at from a systemic standpoint. So we don't care what the widgets are in between. We are seeing how they operate well together.
And
Sorry, you were about to say something.
well, the reason why I was asking that is because it would imply that maybe you guys are equally affected by shifting trade policies, where you might be designing something where some parts of that outside in just changing. And so I'm trying to understand how you're impacted by this, how that changes how you guys think about your product development. How do you think about iterative design?
That's a fair question. So from a system software perspective, it's reasonably okay, I believe, right? We're still working through all of that. We comply with all the export control requirements that are imposed. Certainly, the intellectual property itself for systems does have constraints on if it goes beyond a certain expected performance level, then there are constraints on to where it can go. The software design perspective, which is purely for simulation purposes, etc., should be somewhat cleaner. So far, we haven't reached the levels of specialized performance that forms bars, but certainly if you look at the schedule for export control that ECCN draft has, we do have some constraints that we're constantly following. So yes, we have to be compliant, we have to be cognizant. There may be impacts. Right now, they're still up in the air.
Talking about up in the air, valuations for this space are always up in the air. And I remember back in the day where all the fiber was being laid between all the countries that saw the future of the internet, and we had all this dark fiber everywhere, and all these companies were hyper valued. I look at the stocks that define this sector, the TSMCs of the world, the
Mhm.
I guess AMSLs and the Samsungs, Apples, and you just look at enterprise values that are off the charts.
Mhm.
Um, this isn't a analyst call where you need to make a comment officially about this, but where do you think the value lies long term? Is this a bubble in effect?
Fair question, right? So I am amazed at the valuations that we're seeing. Some of it may be justifiable because a number of the companies with those valuations are showing real growth towards that path. They may be, if you look at forward growth, you may actually see that it's not as bad. If you look at the PE trailing 12 months, it looks exorbitant, but a number of these companies are still growing at very high CAGRs. Even Nvidia being valued at 2.5, 3 trillion at the beginning of the year, now it's at past four. If you look at the growth is almost startup-like, right? Even at those big numbers. So some of those values may be justified. Now the question is, can the market sustain that growth? That remains to be seen. Is AI kind of paying for itself or creating the growth thereafter? It's still TBD. I think some of these things will settle. Like most things, there's always a growth phase and a maturing phase. Right now, I think AI is still in the growth phase. If you look at startups, there have been plenty startups that have come and gone, but startups are still being funded by VCs, which tells me that there is still appetite.
Yeah, there is plenty of appetite, but we just don't know if we're paying the right price anymore, especially in this
Fair.
sector. I mean, I guess because we're talking about investors, pretend you're an investor. I'd love to hear your thoughts. You can answer that question either from a public markets point of view or from a venture capital point of view. But what are the opportunities you're seeing right now in this space? Like if you had a team of 5 colleagues and you're basically you were able to allocate, maybe 200 million, what would you focus on?
So certainly compute is, I'll speak from a semiconductor standpoint at the moment, right? I can claim to understand what makes AI companies successful, but I would argue I'm not best set up for it in software. But you can see companies like Perplexity, et cetera, growing radically with small teams of engineers. They've actually generated tens, if not hundreds of millions in revenue over a very short period of time. So the growth is there, the market is there for certain things if you see them. From a semiconductor perspective, I would kind of look at compute and distributed compute as primary. And then obviously there are things like quantum that have been growing. We're still trying to sort out whether it comes mainstream and where. So to me, communications and data movement is where a lot of the bottlenecks are today, right? And so that's why companies like Broadcom, Marvell are growing rapidly. That's why you're seeing a large part of NVIDIA's explosion is they solved their local data movement problem. They acquired a company called Mellanox maybe 7 years ago for a paltry sum of $13 billion. If that company was on its own today, if you pulled that portion out of NVIDIA, that'd probably be 10x to 20x of where it was then. So you're seeing a lot of work on optical networking as optical comes both. Traditionally, it's been in data centers moving across. It's coming closer and closer into silicon. So that's where a lot of that innovation is and potential upside is. So from a semiconductor standpoint, I see a lot of data movement companies being interesting. I see quantum as still scratching the surface, still has to prove itself. And I do think that there are specialized niches for AI that require custom or a specialized hardware as well, which actually can change the game. So if you think about AI as this large beast, what makes AI is the ability to aggregate more data, convert that into information. The more it gets into everything and the more it democratizes value or cuts cost in the points of both entry and return, right? And the better it gets. So you will see specialized hardware for near sensor, specialized hardware for near. So from that standpoint, I think there's a lot of value in specialized hardware acceleration, which is why that appetite still is there. Now, that may not be the area we're going at. I was trying to focus on the market I've been closest with.
I mean, I think that they're all topics that we're looking at as well, with the exception of quantum, which I think we're a little bit early. All those other ones we're actively looking at. I think the hard part is discerning how much money they need at the start.
Yeah.
Some of these are incredibly difficult to figure out, and also how long it takes for them to show anything, which is sometimes difficult for smaller funds. And it's not clear whether or not the bigger players will roll things out. And so, it is an interesting space. Do you think you'll ever want to be an investor?
I do think I will be. I do think after I'm done with this, I assume I have learned enough that I want to. And as you say, past performance is never a
So,
good indicator of future. But I do think that this is an exciting time, but also a very dangerous time. If you enjoy the exhilaration of fast fail, pivot, and redo, then yes, you'd like to be an investor.
I mean, part of being an investor is knowing what kind of advice to give. And,
Hmm.
the technical stuff fades with time, but the more human side of things doesn't. And you've spent a lot of time either selling
Hmm.
in or to
Hmm.
deep tech companies. And now in your
Yes.
role as chief commercial officer, I suspect that if I forced you to write a book, a lot of the lessons would be on that subject. So if you had to give the top three lessons learned as, CCO and any other commercial role in this space of selling into other complex manufacturing or deep tech companies, what are the three lessons that you would share with a founder you just invested in? As you're a new angel investing, you just invested in, what are three commercial pieces of advice you'd give them?
So for a new investor, right? The actually one of the earlier startups I was at, the CEO said, I'm not looking to build the perfect product. I want to find the perfect partner to help me build the perfect product, right? So if I'm going to actually uh, invest in you, I want to understand you have the technology that can make a difference, but I really want to see you build the right relationship to learn fast from it. So if I get there to 70%, but you identify the people that you're going to work with that are going to make your product better, win them, and then optimize the product from there. So that's one clear lesson, right? Especially for a young company, focus is important and finding the right partners is important. And that was equally a lesson that I learned at ARM as well, right? So ARM was a big company, relatively 200 million profitable, but it found the right partners to scale. So that is equally important in a startup founder to have the vision to see who will be the players in their customer base that are going to make them more successful, right? So that's, I think, important. And that may be one statement said, but there's a lot leading into that. Right. The second thing I would say is dream big, but plan small. It's easy to look at the scope of what you're trying to do, but until you put those blocks in place that'll help you get there, losing that focus can be extremely detrimental because you are probably one of 1,000 players that want to play in this space What makes you different is your ability to focus and execute while keeping an eye on the big picture. And the third thing is learn fast. The fast fail pivot is not untrue. It's trite, but it's still critical for success.
But how do you do that in an industry where like spinning dies and everything else is in a 9 month schedule through a fab? I mean, how does that work? How do you learn fast without burning cash in this space? This software is where you do that. How is this
Mhm.
industry like that? Walk us through how you think that.
So, very good question. And that's actually where a lot of Baya's focus is, right? So, our focus is we're not actually building the chips, we're helping people build chips. And our focus is in saying, okay, if I were building the chip, what would I do to make that fast, right? So, that's why the more insight you have. So, what Baya does, in fact, what is different, and thanks for kind of leading me to that question, is we do software defined system design. So you analyze, you try different workloads, you see if it's working, and then you build very quickly the hardware components that are needed for it and connect them all together.
Mhm.
So really, it's much more software mindset and a data-driven design mindset that makes it fast and agile, right? And if we provide this capability to our customers, then they become equally agile, that they can optimize and move alongside. And so even late in the process, right? So as you kind of point out, 9 month silicon design, it's an expensive process. And especially the physical implementation is a very laborious process. And we try to make that simpler by allowing them to break these things into small modules so you can actually
Mm.
optimize each and in place. So agility is kind of built into how we help our customers design. And that allows people to say, okay, I just found out that nothing stays static in this industry. I just found out 7 months into my 9 month design cycle that suddenly when it comes out, this type of workload is going to be a lot more important than what I started with,
Mm.
right? So you have to be able to adjust your design for it and then have the resiliency in the components that you build that you can future proof it. So you have to start looking at what are the avenues that it may need.
Yeah.
So you build those into the design so that once it's out in the field, you can still do it, right?
Mm.
Post silicon route planning, telemetry to help you monitor it. All of those things have to be thought through.
Yeah. No, fair enough. And some of that stuff might be automated now with more and more AI tools that you can almost predict these in much better ways than before. And I think it would be amiss if I didn't go deeper into AI in this, but you had a thought.
Yeah, no, indeed. And that is exactly, you seem to be reading my mind and leading me towards my narrative, right? So part of the change that we did when we started this company was, it was easy to say, okay, I'm just going to put these drag and drop blocks and I'm going to build a system. Now, reality is it's not at that granularity. You need to be much more granular than that. So the company was founded by, I mean, the CEO and two others. They had done a similar one. So this is effectively a third generation company, right? And what they learned from the first one, which was acquired by Intel back in the day, was that actually I need to give more flexibility and control to the designer to do this. And it's going to get more automated. So we actually designed our interfaces with Python, which is very familiar to most software developers. So it's easier to find the right people for it. And it's also the interface that we use to do work post silicon. So any AI tools that need to utilize that, read from it, and optimize it in field are naturally fitting the new paradigm of AI-driven optimization.
You're basically telling me that we can now vibe code semiconductors. Is that what you're telling me?
It's going towards that. It's slow but steady.
Wow, that's awesome. But let's keep on going on the AI side. First of all, before we go deeper, I want to touch upon talent. Are you guys suffering from any of these poaching issues where people are offering 750 million packages to your people to poach them? What are you guys seeing in talent in this space? Is it really difficult now?
It is difficult. Our poaching challenges are probably an order of magnitude to two orders of magnitude less than that, right? But the semiconductor industry itself, when you look at the giants like NVIDIA, when you're getting large paychecks and you're getting your equity moving like a startup anyway, why would you go to a startup, right? So we do have that challenge. It's a non-trivial problem, and especially in data movement, in fabric design, network on chip, it's a very small sliver of specialists that we need. So we're actually trying to play a slightly different game of bringing in precocious junior talent or mid-range talent, marry them up with the founders and the passionate leaders we have to kind of bring them up to speed faster. So there's a little bit of a learning curve there, but at the same time, it has its additional advantage that the guys coming in already are AI friendly. They bring in their innovation and innovative ideas. So we're trying to use that as a feature rather than a bug.
Makes sense. I mean, we're talking about record levels of youth looking for good jobs, especially through AI. It sounds like you guys are going to be facilitating that for those that come from that world. So maybe let's go
Making a
deeper.
virtue out of necessity, if you will.
Exactly. Yeah, it makes sense. And if we go back to this sort of somewhat meme-ish version of vibe coding semiconductor chips, what are the things that you're looking at from a science fiction point of view that, maybe 3 years ago you were like, wow, I can't believe this is happening. And that if you take that same view and you fast forward it, that you think, in your career you will see, like in terms of whether it's integration of hardware with AI, the nature of how AI is manifested physically, edge AI. Just throw some crazy conspiracy theory level ideas out there, Nandan.
Fair question. If you told me 10 years ago that I'd have chips that could connect with my brain, I'd have said that was sci-fi. That's almost being tested at FDA levels now.
Mm.
So we've already connected past that. I do think that physical extensions, right? So when I'd say that, I'm like, hey, I have a device that's very close to me that is already predicting what I need to do. You could argue your smartwatch is beginning to get there, but there will be even more interesting form factors that are not as a watch was a lot less intrusive than a smartphone, which was a lot less intrusive than a laptop. But
Mhm.
now you've seen the Oura rings talking about sleep. But what if that was not just about sleep, but much more than that in terms of health? Right. Secondly, beyond that, you've already talked about so 10 years ago, we talked about an insulin pen that could work without batteries. Now, the same thing, which is automatically monitoring your customized body situation and maybe giving you the dose where you need to without you having to think about it. Those are the kinds of things that change. So, what I feel that will change radically is the personalization. So I think healthcare probably benefits the most if used right. I may not come up with any radical things that you may not have already thought about, but certainly every aspect of your daily life that needs automation or prediction, I think will change. Yeah, I'm not being very visionary, am I?
But when you look at it that way, I'm trying to think about it from the point of view of what is the volume of chips that will be required to fulfill that vision. So, like, let's play with that for a second, right? So,
Hmm.
if I polarize the world into high compute chips that are high margin, expensive, think about your average, high end GPU. And then on the flip side, you have super, super cheap compute, low energy, low cost, but can be used for edge devices on low power.
Hmm.
I'm trying to interpret what you said in a world where the volume of those two, like if you had to pick based upon what you said,
Hmm.
which will generate more cash for investors? This side, which is the big chips that do cloud level stuff, super fast, super deep, or the edge ones might be cheaper, less margin, but maybe much more of them on your finger, on your ear, on a drone. Which one of those is going to be the one that drives what you just predicted?
So I think the edge is always a margin play. So in terms of return, I don't know whether specialized solutions there unless they're very, very deep healthcare, and it's not going to be as prolific. Those will always be there, and they'll be, I think, value gain. Always the margins end up being on things that are very expensive to build by somebody, right? So I don't see the layer changing for where the margins will be because just a cost of a new design can get close to $1 billion now, right? So when you have to play that game, not that many can play it. And in order to do that, they have to build the margin in. So I think in terms of growth and value, it's still there. But in order to make the services possible at the other end, I think the consumer side and the low cost chip side is actually going to be arguably subsidized by the service that is going to be provided with it. So, for example, if I do an ECG device that I can take everywhere, it has to be cost effective, and hence the margins on those devices are not where you're going to make the money, but it's on the service that you make the money. So when it gets to consumer, my view is that those will be subsidized by the OEMs or the service providers that will provide you the service, which is value added. The chip, while it's different, is not going to be where the margin is. And just on that front, right, you will start seeing more interesting technologies appear. You've probably heard of Pragmatic. It's based in the UK, Cambridge-based startup that's trying to do foldable chips. They're not designed for high end, they're very low end, but they can go everywhere. So that would mean that the volumes could go even higher on things that you don't often do. And when we were thinking about that, you could actually see school kids making their own chips because it's an easier manufacturing process. Can you actually make your own chip, right? So you did 3D printing, I can do that. Can you make your own chip? It's not the high-end data center one, but I needed that because I'm going to write this software for something that I'm going to wear or something I'm going to do around me. Is that even possible?
Every industry has an uncomfortable truth. Some of them are easy to point out, like for example, late 2010 or so, the solar industry funded by venture capital in Germany and in Europe was mostly government subsidies that kept it afloat. And
Hmm.
that was an uncomfortable truth, right? And that ultimately, when that ceased, then that whole industry collapsed and is now has a reemergence in other parts of the world. What is the elephant in the room in your industry? What is the thing, the uncomfortable thing that maybe isn't talked about enough?
That's a good question. One thing I would say overall is as we get further and further into angstrom levels of um, semiconductors, right? We've always talked about Moore's law, which was getting no longer holding, for example. I think the cost of constantly changing that has been done mostly by the industry itself, but I'm guessing part of the reason why we're uh, consistently getting these high prices is just the cost is going far up. So this is not an unknown truth. I'm just wondering whether that can hold. In terms of the, um, yeah, you probably stumped me on that. I don't have a good answer.
Well, there's probably a lot of them. It'll come
Mhm.
after you get off the
Yeah,
the
yeah.
microphone. You'll be like, those 750 million paychecks. This is an uncomfortable truth. Um, just before we wrap up, I wanted to go back to talent a little bit. Um,
Hmm.
you know, you get to work with very smart people,
Hmm.
and very smart people generally have enough of an understanding of many things very quickly, and therefore can develop a lot of opinions about how to run a company, even though they themselves are not the ones running it. You've seen multiple companies run
Hmm.
between Amazon, whether it be some of the other companies, BrainChip, whether it be, obviously ARM and everything. What is the piece of advice that you would give to somebody who's leading a group of very intelligent people with very strong opinions on how to still go forward and succeed?
Yeah, you run through it every day, right? I would say there is a balance of humility and trust that needs to be built for it. The way I got it described was you should have strong opinions loosely held, right? So you can have a strong opinion because that makes you decisive, it makes you go down a path, but be ready to test your assumption when faced with the right counterpoint. Right? And that also makes the fast fail and pivot work because without decisiveness, without kind of confidence to move in a particular direction, you're not going to succeed. But if you're pig-headed at times when you're getting the signals that tell you you need to adjust, uh, you need to be able to do that. And what I see in small groups, especially, is that comes from trust, right? So most entrepreneurs, innovators are very confident in themselves. They know everything. It's only when they're tested by people that they know are not trying to one up them, but trying to actually move that forward, that you can go forward, right? So confidence has to be there. It's like unshakable confidence needed to get through all these times. But then it has to be the humility and the trust to say, okay, let me rethink this because this is not being told to tell me I'm wrong, but this is what we should be doing.
Yeah. So it sounds like creating a safe space where opinions can be shared, but where people also kind of step away from them a little bit so that you can move
Yeah.
forward. Otherwise, you just keep on ping-ponging back and forth and no movement.
Yeah. I mean, there's almost never a single person that does it, right? You innovate with a collective, but you still need decisiveness.
Yeah, fair enough. Well, I really enjoyed our chat, and then a lot of wisdom there we can continue to unpack. And I'm sure you're going to walk away and it'll pop in your head. What are the
Yes.
uncomfortable
What the
truths
elephant in the room was.
in your
No,
industry?
thanks.
It was a pleasure, and we look forward to seeing your continued success.
Thanks, Carlos. And I really appreciate the time. And this was an exciting discussion. I enjoyed it very much.
Cool.
Cheers.
Well, guys, until next time, see you later.